Welcome to Review Recording 1A to accompany Instructional Recording 1A for Section 4.1 of Unit 4, Chapter 4, Mathematics 2200. We'll be solving quadratic equations by graphing the corresponding function. Example 1. Which value is a zero of the function shown? Well, a zero is any value of x that makes the function itself equal 0. That occurs right here. When x is 3, the y value is 0. And right here, when x is negative 1, the y value is 0. So in other words, we have a 0 at the x-intercept, at each x-intercept. So let's see, we have negative 4 is not one of our two x-intercepts, negative 3 is not, negative 1 is, and C is our correct answer. Our next example requires a little more work. We have to solve this quadratic equation by graphing. So we write the corresponding function. That is y equals 2x squared plus x minus 3. To begin our graphing, we'd like to know the value of negative b over 2a. That'll give away the vertex. Our b value is 1, so it's negative 1 over 2 times 2, which is negative 1/4. So I start to create a table of values. And the negative 1/4 goes in, and I do the calculation. 2 times negative 1/4 squared plus negative 1/4 minus 3, which equals 2 times 1/16 minus 1/4 minus 3. This will give us 2 going into 16 goes 1, so we got 1/8 here. Minus 1/4, that's negative 1/8 minus 3. We've got negative 3 and 1/8. So our vertex is at negative 1/4 of a unit and negative 3 and 1/8. Somewhere handy around here. And this graph is going to open up. Now, next. We'd like to pick some convenient values for x. 0 and 1 wouldn't be too bad. When I put in 0 for my x, that's going to give me my y-intercept, which is negative 3. Put in 1 for the x. I've got 2 plus 1 is 3 minus 3 is 0. Wow. We've got our y-intercept at negative 3. And we've got 1, 0 as a point on the graph, which gives us one of the roots of the equation. Now, keeping in mind, I've got a 0.1/4 of a unit or 1/4 of a unit to the right of the vertex. My axis of symmetry is at x equals negative 1/4. So I go 1/4 of a unit or 1/4 of a unit to the left. My x-intercept I found is 1 and 1/4 units. Here's 1 full unit plus another 1/4. So I've got to go 1 full unit to the left, brings me to negative 1 and 1/4, plus another 1/4. So it brings me right to here, which is at negative 1.5. So with a bit of accurate graphing here, I've got my other x-intercept, negative 1.5 and 0. So our roots are located at x equals negative 1.5 and x equals 1. They should balance that equation. Let's check that. So I'll check the x equals negative 1.5 first. We've got 2 times negative 1 decimal 5 squared plus negative 1 decimal 5 minus 3. That's supposed to equal 0. Negative 1 decimal 5 squared, that's 2 decimal 25. And then we're minus 1 decimal 5 minus 3 here. 2 times 2 decimal 25 is 4 decimal 5 minus 1 decimal 5 minus 3. Yes, indeedy, that does give us balance in the force, as they say in Star Wars. The other one, x equals 1. 2 times 1 squared plus 1 minus 3. Does that equal 0? We've got 2 times 1 squared. Well, 1 squared is 1 times 2 is 2. So we've got 2 plus 1 minus 3 equals 0. 0 equals 0. Always a good idea to check your roots when solving by graphing because graphing is so difficult to do accurately. In conclusion, if ax squared plus bx plus c equals 0 represents a quadratic equation, then the corresponding function is y equals ax squared plus bx plus c. Or, using the f of x notation, f of x equals ax squared plus bx plus c. The roots of a quadratic equation are the same as the values of the zeros and the x-intercepts of the corresponding function, and a quadratic equation can be solved by graphing the corresponding function and finding the x-intercepts.